So did you switch it out for a dead baby?
No.
Oh, okay.
She like turned it back. So I was taking them home today.
Oh, okay.
But my friend has it right
Oh. So did your baby cry all the time, or just quit and didn't cry again?
now.
Mine cried the whole time.
It just cried in this period.
All weekend.
Holy crap!
Yeah.
Oh shit.
I feel the same way.
What happened? They're both here.
They're both here. I had seen them in like a minute. I mean, like a year.
He was like, that makes me old.
Now I asked this question of one of my students in fourth period, and they told me it was tacky to ask this. But I asked him why I showed up once every blue moon, and he told me he was just not 16, so he couldn't drop out. So why are you two here? He told me the police made him come. He didn't have an option, so why are y'all here? Oh, you just here?
Yeah.
Oh. Should I expect to see you tomorrow?
Yeah.
That sounds suspiciously like no. Guess we'll see.
It was more than we showed up.
Must have been.
What opening is this?
Six.
No, I just came up here just to walk around.
Lloyd, move up a chair. You're not gonna just come in and sit down for me. You're right. We're going to talk to him outside school. Well, look, it's not Jada. Tyler's here. Elisa's here. Grace, he's out. Urelli's not. Oh, I need to give you a Saturday school contract. Joseph signed his. I need to give you one. Why are you here and all? He's got to come sign. Hold on. Stand there. Eric's here. Probably came in late, but I didn't see it, so it's fine. Carol, Damian, Janelle, Joseph, Mario, Trevor,
What was the period?
Jose, Liliana, Nigel, and Eduardo. Alright, let's see how many days you've missed.
Isn't it going this way?
Well, it's got to go on the contract. There you go. Know your ID? What? Joe, come back over there. You're not just coming in here to sit and socialize.
I wasn't socializing. I was saying what?
Right.
Doing some stuff.
No, I can hear you. That's how I knew you moved.
I was more
I'm gonna get some water.
Can't spell. Time for torture. I don't understand it.
Okay, I'm gonna copy and hand it to you in just a second. I'm gonna make a copy. I have to have proof that I gave you one. Yeah. Yeah. Well, it has my name on it, you can white it out.
A kid asked me for one of that. I said, well, I couldn't find the ones I had from, even ones I filled out.
There you go. Just, yep, and where I signed there, just wipe that out, and those are the Saturday school days for this year. I think that's 31.
All right, thank you.
You're welcome.
I don't have that.
That's a start, that's start, but, no, like, that's the white.
There you go.
Oh, shit.
Now, the opening is to review for quiz we have tomorrow. All right, remember, it's on the parts of the periodic table. Got done, Diablo? Got done?
Yeah.
Got it.
Yes.
All right, we ready to go over it? All right, so question one. How many groups are there on the periodic table? 18. What direction do they run, Tyler? What direction do groups run? All right, up and down. What other word can we use? Take your little sunglasses off, please. Mario. Sunglasses off. No, take off. Vertical is another answer you could use. Up, down, vertical. Columns. All right, number two. How many periods are there, Jose? Don't look at her for the answer. How many periods are there? 7. There's 7 periods. Which direction do they run, Isella? Horizontal, left to right, sideways. I take any of those. All right. What's the name of group 1, Mario? Alkali metals. What's the name of group 2, Elizabeth? That's a great name.
The A word. Metals.
Alkaline
Alkaline.
earth metals.
Metal.
All right. Number 5. What's the name of group 14? Diabion.
Number 5.
Yeah.
Working.
What's the name of group 14?
I put carbon family.
Carbon family's correct. All right. What's group 17's name? Nigea. Halogens. That's why they're called halogen light bulbs or halogen lights. All right. What's the name of group 18? Grace.
Noble gases.
Noble gases is correct. What do we call groups 3 through 12, Ochanel? That big middle section on your colors periodic table, what do we color it on Friday?
It starts with the C.
Starts with a T. Were you here Friday? That's why you don't know. All right, Markel, transition metals. All right, what do we call the numbers 58 to 71 on our color table, Nigel? Lanthanide is correct. All right, what are the two liquids on the periodic table? Tyler? Two liquids. Put L's in them on your table if you participated. You put L's in them. Take your Tic Tacs out,
Oh,
put them in the
yeah,
case.
what's that called?
Hg is fine, mercury,
And bromine.
bromine. I done lived with the symbols if that's all you knew. Hg and Br, or mercury and bromine.
I forgot we put L's in there for liquid.
Yes, put your Tic Tacs up. All right, number 11. What elements are gases? Diavion. Yes. You could just give me a grouping of them and name the other 5.
The noble gases,
The noble gases,
fluorine and chlorine.
chlorine and fluorine, so Cl and F. Okay, Cl and F, and what are the other 3?
Oxygen.
Oxygen, nitrogen, and
I couldn't find the other one.
H.
Oh,
Hydrogen. H.
that's all the way over here.
I know. Where are the metalloids found? Joseph, hush. Where are the metalloids found, Grace?
What number is that?
12.
I don't know. I can't tell.
Where are the metalloids found, Estella?
What was it called?
What do we call that?
Yes.
On the staircase. The metalloids are on the staircase. All right, where are the metals found, Jose?
No.
I give you a hint. It's based on where the staircase is. The left or the right?
Left.
Okay, look at the table that's up there. Are the metals in the blue or the yellow and the orange?
Yellow and orange. The blue.
Metals are in the blue. So are they on the left of the staircase or the right? They're on the left of the staircase. All right, so for number 14, where will the non-metals be? They're on the right of the staircase. All right, find y'all's periodic tables from Friday. We gotta add one more thing to it, and then we're done. Now we'll put your phone up.
I used to text now.
No, you may not use Tic Tacs the entire class period. You can put away. All right, we have one thing to label on our periodic tables. Joseph, Louise, would you like a periodic table? I know Odell wants one.
I got one of that.
I had a feeling. When you're not coming back tomorrow, it don't really matter if you got one today.
Who says?
Oh,
Money on?
Yeah, I'd be glad to give you one.
I thought you bought one. I thought
You
you
don't
bought
do anything.
I'll try.
Put your phone up, folks, now.
Got bananas in it?
You know, I'm a lunch. All right.
Just take this one.
All right, so at this point, the only thing we didn't get to Friday to label on our periodic table are outer shell electrons. So, pick something, I don't care what, to label outer shell electrons. All right, you choose. also has another name. It's called valence electrons. And I will use the names interchangeably so that you're used to both names for the exam. Now, when you guys made your Bohr models, all right, what element did you use, Nigel? What element did you have?
I had
Chlorine. How many electrons did you have on your outermost ring? You remember?
I think
You don't remember? You saw what element did you have?
this was with the
Sulfur?
Yeah.
How many electrons did you have on your outer ring?
Wait. It's like
2, 8, and 7. You had 7 on the outer ring. Yeah, that's right. Remember how many you had? You had 2, 8. You had 16 total.
Yeah.
So you had 2, 8, and
Wait.
2 and 8 are 10.
Yeah.
So how many more would you need on that outer ring? 6. Okay. What element did you have, Elizabeth?
All we know is aluminum,
Aluminum.
had 2, and inside, and 3.
3. So you had 3 on the outside ring. All right. Yavian, what did you have?
Potassium,
How many did you have on your outer ring?
19.
You had 19 total. How many were on the outside ring? That outermost ring, that last ring.
I had like 2. I did it wrong.
Yeah, but how many were supposed to be on the outside ring? What?
Just one.
Just one.
Because it can't be more than
Okay, just one. All right, so, but y'all all had to draw Bohr models to figure it out. You see how y'all were counting the 2, the 8, and then adding it up to figure it out? There's a shortcut for that, all right? So we're going to learn the shortcut so you don't have to add all that up. So group 1, everybody in group 1 has 1 electron on that outside ring. Doesn't matter how many rings it has, they all have 1 outer shell electron. Everybody in group 2 has 2 electrons in their outer shell. All right? Everybody in group 13 has 3. 14 has 4. 15 has 5. 6, 7, and 8. So when I graded your Bohr models, I was able to easily check to see if you had it right. So Elizabeth showed that she had aluminum. Aluminum was supposed to have how many electrons on that third ring? 3. Isella said she had sulfur. Sulfur was supposed to have how many? 6. Chlorine was supposed to have 7. Potassium was supposed to have how many? 1. Okay? Did those people have those? Mark out which ones you did. Calcium's here. How many should have been on his ring?
2.
Who had argon? Anybody have argon? I know I assigned it to somebody.
Oh, I do.
You had argon? How many should you have had on your outside ring?
Oh.
All right, look at the chart and tell me how many you should have had. Argon is here.
Hey.
You should have had 8 on its outside ring. Okay? Questions about that? All right, so
What about the middle?
the middle, this whole section, y'all are not responsible for that, but these would all have 2 electrons. The whole section would have 2. And because this was cut out of the middle, these would also have 2. All right, but you guys will not be responsible for anything in that section. All right, it's not part of your curriculum, so we will not do that. All right, we're doing what's called main group, and main group only does groups 1 and 2, and then 13 to 18. All right, questions about labeling on the periodic table, because we're going to practice for our quiz tomorrow. All right. All right, let me pull up clickers. All right, we're not doing a Kahoot because so many people don't participate.
What?
hate this keyboard. All right. Should be good to go there. Down to the bottom. Class roster. There we go. All right. Should have everybody in here. All right. I should have Luis is in here. Jose's in here. Joseph's in here. Yep. I don't see anybody who's missing. So on my desk are the clicker cards. Find your card, please, so you can participate. Now, if you want to use your color-coded periodic table, feel free. This is review for our quiz tomorrow. Everything else, if you were absent, of course, you need to get the color coding from someone, okay? Now, it's uploaded on the website, so you can always color code it based on the video and just skip to the parts that you need, all right?
I can picture that real quick.
Two. All right, we ready? All right, using your periodic table. Tell me how many outer shell electrons sulfur has. I need you to hold the card up, not your hand. Derek, I need you to get your clicker cards so you can participate. I need you to put your phone up so you can participate.
You can multitask.
No. Elizabeth. All right. Mario. Bobby him in the head. Get a clicker card so you can participate. You had the option last year, Pat's my class, not be back in here, so go grab a card. All right, so How do we get 6? Y'all fun.
Because two made 6.
All right. Remember, outer shell electrons count across. 1, 2, 3, 4, 5, 6. Sulfur's in this group. That's outer shell electrons. All right. If it scans you and you weren't ready, just hold it up again and I'll rescan you. All right, who am I missing?
Me?
All right, group 1 is called the alkali metals. We see that tomorrow on the quiz.
Side up there. Yes.
Oh, I didn't show y'all that name. Y'all are all gonna get this one wrong.
Sure.
Well, maybe not.
Here.
I should have used the process of elimination to get it right. All right, the chalcogens is the other name for the oxygen family. The reason I said you should be able to use the process of elimination is group 17 is called the halogens.
They're already on.
The noble gases is group 18, and the carbon family is group 14. So the only one left was the chalcogen. Which one's the liquid?
Here.
I'll give it a second. Give everybody a chance. Makes it easier if I've got more to scan at one time. Thank you, Joyce.
Well, you ready?
No problem. All right, the only one I missed is Derek. All right, iodine's a solid, chlorine is a gas, and nitrogen's a gas. I gotta get it right now?
Yeah.
Why, are you bleeding? Like where?
You don't see nothing here.
Really? Okay, dude. I was thinking, you've got some major blood gush or something. I can barely find it. All right. Wait a second to hold it up, just to figure out which one's the metalloid. Yeah. Here, Davion.
So nice. Thank you.
All right. Look, dudes. It's calling me. Clyde, go away. No time for this. All right, who done miss?
Me.
It's me.
Not there.
Did you get mine?
I think so.
You got it.
Yeah. All right, see how we did. Not bad. Three of us picked magnesium. Magnesium's a what? What's magnesium? It's a metal. Here's an easy one. Yo, Derek.
Hey, no. Is it here? You can deck that. Your husband have a crane.
Jose?
Yeah. It looks good. So it does.
Not bad. What's the name of group two?
Well, you need to give us some hard questions.
These are gonna be similar to what you're gonna see tomorrow. It's largely memorization. Do you know the parts? Modules up there, guys. Not bad. Oh, no, that one. Somebody hit the mouse.
Did you get mine yet?
No.
Oh, wait, no, I just didn't know.
Number 18.
Oh, thank you. Okay, I'm ready.
Still need several people. Jose and Joseph for my two. Gotcha. Jose, you got it? Why's it 8? So we've got a couple people who got it wrong. So why's it 8?
This in group 8, this in group.
When you count 1, 2, jump the transitions, and it's 3, 4, 5, 6, 7, 8. Going across. All right.
Just look at the number. Like if it's 13, it has 3, and if it's 14, it has 4.
You subtract the 10 for the transition elements. All right. Which one's gas?
Oh, I'm dead.
Did I get you? Okay. A lot of times I see it pop up on the phone. All right. Then get Markel. What's going on this?
So you remember my sister, right?
Yep.
She's back from college.
Cool. Where'd you go?
Charlotte. Yeah, there was a shooting a week ago.
Yeah. You doing okay from that?
She's still kind of like, she just doesn't want to bring it up.
I understand that.
Yeah, she feels really bad about it. So.
Phosphorus is a non-metal. Calcium and aluminum are both metals, but phosphorus is not a gas. Which one's a metal? Now, this particular type of question is important for our next unit on bonding. You've got to be able to tell metals from non-metals. Okay? It'll also be important for naming.
Me.
All right, so how do we tell where the metals and the non-metals are? Because we got bludgeoned on this one. 33% of us got it right. All right, I want you to look at the blue. Okay? You see this blue over here? What is the blue? The blue is metals. That's why on your lab we color the blue as what? Metals. So you've got to actually look up where these things are. Sodium's over here, so it's in blue. It's a metal. Silicon is in green. What's in green? What do we color green on our lab? Metalloids. Metalloids are on the staircase. All right, silicon is in green. It's a metalloid. And then, what else did y'all pick? So we all picked, I don't have it up there. I didn't put the chart up. All right, and then some of you picked neon. All right, neon is over here in the orange. All right, what's over here in the orange? Gases, they're non-metals. Okay, so non-metals are over here in the yellow and orange. Green are the metalloids, and blue are the metals. Okay, everybody got me on that? All right, last question. And then you're just going to need to study for the quiz. What's that colored section? Hey, Derek. All right. We feel sufficiently reviewed. All right. For those of us who've been here and doing what we're supposed to do, you need to study. For those of you who've been absent, if you want, do like Malik did and take a picture of somebody's periodic table so that you can go home and either color code it or study it. Okay? There's not a lot more I can do for you if you're just not here. Okay? Questions? It's not nap time. Find your notes.
When's the days that you guys stay after school, Tuesday, Wednesday?
I said Tuesday, Wednesday, Thursday. Yep, today I have a staff meeting. It's the first Monday of the month. All right, if you will, bring your cards back up here, please. Yes. No, you cannot use Tic Tacs. We've been through this. No. Put them up.
I tried to stop my food, but
My arm probably look like that.
All right, most of this we're not writing down, all right? We're just running through it to review, all right? So don't write. Did everybody hear me say don't write? Okay, we're just running through it to review. All right, I'll tell you when we're gonna write. Which way do groups run? Up and down is one answer you can give me tomorrow. What's another answer? Vertical. All right, I'll also take columns. All right, I'm gonna assume if you tell me columns, you know what a column is. All right, most of you have had an Excel or a Word or a spreadsheet type class, so I would assume you knew that. What's another name I might use for a group on the quiz or test? Starts with an F. What's the other name for group 13? The boron family. So what's another name for a group? A family. Okay. Periods run which way? Horizontal. What other? Side to side. I would take that. Left to right. I would also take rows. All right. Now, if I ask you to tell me the period in the group that AS is in, okay? AS is right there. All right. What period is AS in if I ask that tomorrow on the quiz? What? I hear 3 and I hear 4. One of the answers is correct. Okay. So if I change my color. 1, 2, 3, 4. All right. Period 4. Is everybody okay with that?
Yep.
All right. What group is it in? I hear 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Everybody good with 15?
Yeah.
Period 4, group 15.
Uh-huh.
All right. So if I ask about platinum, platinum is in what group? I said what group?
10.
It's in group 10. And what period? 6. Everybody good with that?
Yep.
All right. What periods did we say these were? All right, 6 and 7. Remember, I had a little dot there, which was a star. And that was from down there. And this was 2 dots for the 2 stars. And that was from down there. Remember, they were cut out of the periodic table. Do the lanthanides or actinides have group numbers? Did they have group numbers down there at the bottom?
No.
No, they did not have group numbers. All right. If I ask you to name the groups, what's the name of group 1? Alkali metals. What's the name of group 2? Alkaline earth metals. What's this big section? Transition metals. What's the name of this? Group 13. The boron family. What's group 14? Carbon family. Group 15. Nitrogen family. Group 16. That's right. These 4 should be pretty easy because they're named after the first element of the group. So as long as you look up the element of the group, you know those names. All right. This one is called the what? Halogens. Noble gases. This group or period is called the lanthanides, actinides. Now somebody asked me Friday to spell and count. No. But if all you can do is write L for lanthanides or write the L word, is that going to get you credit? No. Now, if you're off a couple letters, okay. Or if it's pronounced the way you spell it, okay. All right. Now, what are the three sections on the periodic table that we've been working with?
What?
What are the three sections? Exactly. Now, because some of you are going to struggle with this, I'm going to draw a short or small periodic table for you, and you need to put this in your notes. Okay? So put the three parts of the periodic table. Write it down. For those of you who typically take notes, this is where your notes start. Okay? Make a rectangular box. Make another rectangle. Okay? So you got two rectangles. Make a square. Make another square. Make a rectangle. Okay? So you essentially have three rectangles and two squares. Now, the periodic table is divided by what? What's the key feature that divides us into our three sections?
The number.
The stairs. Okay? So, I'm going to change the color, but you don't have to. All right? The periodic table is divided by the stairs. So everything on the left is metals. Okay, so metals are on the left of the staircase. What's on the right of the staircase?
No.
Go away. Okay, non-metals are up here. Okay, non-metals are on the right of the staircase. All right, so what is on the staircase? That's right. So, metalloids are on the staircase. Okay, those are the three types of elements on the periodic table. Metals, non-metals, and metalloids. So metals are to the left, metalloids are on the staircase, and non-metals are on the right. Now, you might see a question as easy on the exam as which of the following are metals. Now, it may not be that easy, but it could be. You don't want to get one of those questions wrong. Metals are always on the left of the staircase. Okay? Everybody with me on that? You're like some kind of crazy cheerleader over there. All right, if I waited long enough for everybody to catch up. All right, so now you don't have to write this, but on your periodic table lab that you turned in on Friday, question 10 asked, how is the periodic table arranged? These were the answers I was looking for. I took any of the three, okay? Now, ideally, number one was my favorite, okay? And I told you to look up the answer. I knew that you wouldn't all get it just looking at the periodic table. But number one would have been increasing atomic number. They're in order by number. 1, 2, 3, 4, 5, 6, 7, 8. All right, but if you didn't pick that, that's okay. You could have told me metals, non-metals, and metalloids, which is what we're talking about right now. That was cool if you picked that. Okay. Oh, I forgot. you go. All right. And number 3, outer shell electrons. All right. And some of you told me that. All right. So any of those 3 answers were okay. All right. Now, write this chart down. I'm just telling you, you gotta have it.
School's expensive.
What's expensive?
School. Like,
College?
no, school supplies. Like, take all the school supplies we bought over the past, 11 years, add it all up. Right?
Okay.
That's pretty expensive. Y'all should pay us back when we graduate. For real, bro. Like, give us a check. You know?
Yeah.
Like,
And all the pencils I've bought over the last 30 years, y'all should give me back.
I mean, they should give you back too. I'm like, yeah, give the teachers back too.
Yeah.
Then they just
Right.
be like, hey, it's $5,000. Good luck. You know?
Anytime this millennium.
That won't. Just walk.
Mm-hmm.
We really be out here. Like, you know, it's like, it's crazy. You know?
All right, we caught up. We're running late.
Wait. No. Go. I'm good.
You're good.
Yep. I thought
What about everybody else? You know, Tyler's his answer for everybody.
they're not gonna talk.
All right.
Now they're gonna talk.
Well, some of them I'm hoping will be quiet. All right, tell me what you remember about metals. Something we've learned. So you've learned nothing this year. And tell me something we've learned about metals.
They're hard. They're on the periodic table.
No on that last one. They're all solids except 2. Okay, I can live with that. All right, give me something else we know. I heard hard. I can live with hard. All right, I won't say they're not. They're definitely harder than non-metal, so I'll put that up there. Okay. There are some metals that are harder than others. For example, the transition are harder than group 1 or 2. Let me move that because that's going to be hard to read. All right. So like most of the time when we have jewelry made, where are the jewelry type elements at? Are they transition elements or are they group 1 and group 2 metals? What kind of elements do we use for jewelry?
The harder one.
Like gold, silver,
Copper.
copper is used for
Without
some.
that bronze.
That's also, copper and bronze are going to be used as alloys. All right, what else? There's a major one y'all are missing.
Diamond.
Diamond's carbon. That's going to be a jewel. All right, I'm thinking of metals.
Platinum.
Platinum, okay? They're all in the transition elements. All right, something we've learned, though, that I'm expecting y'all to be able to tell me about metals. And we've studied this semester.
Like recently or like just
In the last few weeks or month. All metals are good. There you go. Here, I'm going to change the way I've got this laid out. We'll just scroll a little bit. All right. All right, metals are good conductors. That's the one I was expecting y'all to remember. All right, there are 4 typical metal properties that most people learn in middle school. All right, those of you who had subs, you might have read about it. All right, but the rest of you who had an actual teacher, they probably talked about these 4 properties. You just don't remember. The reason I asked you about this one is I knew we did it. Okay? Now, one of the other ones that students usually remember, or at least some people remember, starts with an L. It's the reason we use metals for jewelry. Metals are what? Starts with an L. Metals have
Liquid.
No radio, thinking.
what? I heard it. Luster. All right, our metals are lustrous. Lustrous means they're shiny.
Learn that.
Okay? Lustrous means they're shiny. Okay? If they're not very shiny, they can usually be shined up. All right? Now, the last 2 that you should have learned that most people do not remember when they come to me are malleable and ductile. Anybody remember the words malleable and ductile? Okay. Malleable means you can be rolled into sheets like aluminum foil. Aluminum foil is a great example of things that are malleable. All right, it's not the only thing that's malleable. It's just a good example. All right, gold and silver, platinum are all malleable. That's why we make jewelry out of them. They can also be rolled into sheets. All right, people who have big pendants and things made for their jewelry, if it wasn't malleable, you couldn't do that. Okay. Ductile means you can be drawn into a wire. Metals have the most, if that makes you feel better. Okay, so like copper. Copper is ductile. Okay, that's why we use copper in wiring. It's very easy to draw it into a wire. Gold and silver are also very ductile, which is why we use it again in jewelry, because we can make necklaces and earrings and hoop rings and things, or hoop earrings and things of that nature.
Into what?
Jewelry.
Trying
Oh, into a wire. What?
You're not fitted to may I borrow a piece of duct tape and a Sharpie?
Why? Remind me at the end of class. All right, everybody got it?
Yeah.
Now, metals also have the highest boiling point. All right, that's it for our metal properties.
What does that say?
Highest boiling point. That's it for our metal properties. Now, how do non-metals compare to that? All right. Does everybody have what they need? All right, so we're going to go to the top. All right. Now, the thing that makes solid or non-metals different from the metals could all be solids, right? Non-metals, all right, non-metals are solids, liquids, and gases. Okay, they're all 3 states of matter. So it's much more difficult to describe their properties. All right, so can we say that the non-metals are hard or soft?
Yeah.
Not really. Now we could say that the solids are brittle, but I have to specify that I'm talking about what? The solids. Okay? I can't say they're all brittle because are gases or liquids able to be brittle? No. Now, does everybody know what I mean when I say brittle?
Yeah.
Like what?
Can break even.
Yeah.
break easily. Okay, I just want to make sure everybody was with me on that. Now, if metals are good conductors, what are non-metals good at being? Good insulators. Okay, they're good insulators. Now, are non-metals going to be shiny? No, what are they going to be? Yep, these will be dull. Now, are these going to be malleable and ductile?
No, so maybe.
Nope. They're not malleable nor ductile. And they have the lowest boiling point. They have the absolute lowest boiling point.
I'm trying to go to Thailand.
Have a good trip.
This sounds very familiar. So, we're senior
Is
year.
that it for non-metals?
That's it. We compared them all. Now the metalloid list is really short. All right, so metalloids. How do we compare metalloids? Anybody know?
Solids.
They are. They're all solids.
Ow.
Every last one of them. We call these semi-metals or semi-conductors, which means they have properties of both metals and non-metals.
What do you have for one?
I don't know. I put the menu back there today.
That's big. It's not that.
All right. Now, everybody caught up? I don't think I've forgotten anything that we needed to do. All right. That's it for that.
Okay. Moving to break.
All right. What determines the properties of the elements on the periodic table? Why do metals have the properties they do? For example, hydrogen explodes. Helium does not. Both of them are low density gases and they float. For example, let's say that Mario wants to send Lolly some flowers and balloons for her birthday. He's a nice boyfriend. He's going to do that. Okay? But the florist uses hydrogen in the balloons.
And they blow up.
Somebody at Lolly's house is a smoker. Or they light a flame for some reason with some candles. Whatever the reason, there's a flame around those balloons. What happens to hydrogen-filled balloons?
They explode.
They explode. So the florist, being smart, doesn't use hydrogen-filled balloons, he uses helium. So why is hydrogen bad for the balloons and helium is good for the balloons? What explains why hydrogen is bad for the balloons and helium is good for the balloons?
Hydrogen explodes And helium does not.
All right, why does hydrogen explode and helium does not? What explains that property of the gases?
Because they're different.
Stop beating on the desk. All right?
You did a great job.
Say what? Huh?
Yeah, like hydrogen and helium hurt you.
Hydrogen in the balloon will not hurt you, no. All right, they used hydrogen in balloons, particularly blimps, back in the 30s.
Wait, is that what happened to the Hindenburg?
That's what happened to the Hindenburg. It was filled with hydrogen and then it exploded. Okay? So, why is hydrogen going to explode and helium is not? What explains this is the valence electrons. Valence electrons explain why things have certain properties. Okay? So, valence electrons explain that. Why can you wear jewelry on your hands like gold? For example, when I mix chemicals in here, back when I could wear my wedding bands, all right, I could mix acids in here and I didn't have to worry about whether I got acid on my wedding band. I didn't have to worry about the gold reacting with the acid and causing it to deteriorate. Why? All right, the valence electrons in the gold did not react with anything in the acid. All right, so valence electrons determine reactivity. All the other properties that I have up there, we do not have to know. This is the only trend that is still left in your curriculum that y'all have to be able to do. Stop that. That's the only one you have to know. Write it down. Okay? You're trying to whistle, so stop.
Trying to whistle, I have a whistle.
Stop doing it with paper. It's irritating.
Because of their reactivity. You're supposed to write that?
Mm-hmm. This is the last piece of the periodic table we all have to know. They've taken atomic radius and size off.
Is it gonna be on this?
You have to be able to do reactivity. We'll finish it today and tomorrow, and then the test will be Thursday.
That's a little.
And it will probably be your last test.
Short notice.
It's already made.
How many more days do we have?
Last.
Like 20?
I think I counted 24, so take today off 23.
So like 23?
I think there are 23 days left.
I don't know if that's what she meant. Oh, too long. That's good.
And that's counting in exam days. So if you've got days you don't have an exam, it's less than that.
I'm only coming for this. And
We test
My
ourselves
fourth
and Miss Taylor, we'll have to
You'll have less than 23 days. All right, everybody got it? All right, now, let me see. I may not want you to draw that. Hold on a minute. All right. Do y'all remember how to do outer shell electrons? Or do we need to talk about this? All right, let's do this. Let's talk about this, and if we need to, I'll go back to the previous slide. All right, tell me the number of outer shell electrons in each of the following. Everybody do it by themselves.
like off our head.
Yeah. Use your periodic table.
Oh, okay.
I don't expect you to have the periodic table memorized.
Okay.
Now, at this point, I would hope that you could do like Nigella did and pull out your orange one and do it instead of having to use the color-coded one. But if you still need the color-coded one we did this morning with it written on there, then do that. But by tomorrow, you need to be able to find it without using a color one, right? Because you're going to have to do it on the quiz.
Yeah.
Okay.
Why would you need to
First one, do we?
Just write it down.
We wrote that.
I mean, you can write it in the margin of your paper, so if I call on you, you can tell me. Markel, you got them? Why do you want that hat?
We've been wearing that for a long.
I know.
It's a beanie. You should have let me.
Let me go ahead.
The rest of the time.
I forgot to tell you, take it off, take it off.
He didn't confuse the name.
Wait a minute.
Must have been blinded by the lights if you're sitting back there by the sun. You got sunglasses on, I forgot that. They're not even supposed to be up there on the top of your head.
Why can't we wear this?
That's a good question.
It's in the dress code.
What?
It's in the dress code.
Dress codes are pretty cool. Isn't there ever a change to spot policy?
I'm not worried about spot, it's always about the dress code.
I have the worst lessons of sophomore year, first semester.
Shocking.
But what was he wearing?
I thought it was
Sunglasses?
my freshman year.
Because I can see why you can't wear sunglasses, but like I don't see why we can't just wear like regular t-shirts and stuff.
Alright, you got them?
Yes.
Do I need to wait longer or what do we have? Alright, Oaks, now how many outer shell electrons does aluminum have? 3. Very good. How many does sulfur have, Jose? You better not tell me you didn't do this. I'm gonna walk over there and pick up that baby and throw it across the room.
You should have done
Because if you're not gonna try to pass my class, I'm gonna make sure you don't pass parenting.
Oh my God.
She's gonna kill that baby.
He's already got a kid on the way. Get your luck. Needs practice.
6.
Right?
Isella, how many for nitrogen?
5.
Alright, Malik, how many for potassium?
it.
Okay.
Okay.
Why are you here?
Because I have to.
You do not have to be. Okay, had how many?
1.
1 is correct. Chlorine has how many, Luis? I gave you a periodic table by law.
7.
Thank you for helping him out back there. Alright. 7 is correct. It's in group 17. Turn the periodic table over and you might find the element. Alright, group 17. Alright, and argon has how many, Joseph? Never mind. Markel? 8. Alright, are we all okay on that?
Yep.
Alright. Now, from there, we need to figure out how does the outer shell electrons determine reactivity. Alright? You might remember this if you had an actual teacher in 8th grade. Alright? All atoms want a certain number of electrons.
Right.
Alright? The question is, how many do they want? Does anybody remember?
18.
They want how many?
8.
8. Alright, they want 8 electrons. All atoms want 8 electrons. Some of y'all might want a college degree. Some of y'all might want to get married, might want children. You might just want to be a sloth. Okay? Sit at home and do nothing. Alright? What? I was not going to say that. Good Lord, people.
She thought it first.
No, I was looking at Jose over there. That would be a sloth. Alright? I was thinking about my son. Now, if you're an atom though, they have a singular goal. They want 8 electrons, which will lead us into our next topic, which is bonding. We'll talk about how they go about getting the 8 electrons. But these 8 electrons tell us reactivity. All right? So, how do they get these 8 electrons? Well, they can either lose electrons, they can gain electrons, or they can actually share, but I'm not going to talk about that today, in order to get these 8 electrons. So we have to learn which groups up there lose or gain electrons. That's our goal.
All of them.
Nope, we got to know which ones do which.
Some of them.
Yeah, some of them. We all want to leave. We all want to go home. We all want summer break. We're not there yet. So my best advice is to suck it up and get over it.
Can I go?
Sure.
Thank you.
Should have said no. This is your last year?
Nope, it's 2 more to do.
Some more.
Yep. Y'all need calculators. Not tomorrow either. When you come in, you don't need it then either.
Well, you know, I was doing something in math.
Oh, you were doing somebody else's work in my class? Oh, that's good. At least you weren't on your phone. I should be thankful. You were doing some academic work instead of watching a TV show.
Actually, I should be doing it right now, but, you know.
All right, is everybody caught up? I've given everybody enough time. Get off there.
It's a call.
Excuse me.
Go sit down. All right, so we need to talk about which groups will lose, gain, or I don't want that. Let me get rid of that. All right. So we're going to start with sodium to illustrate this. Okay? Sodium has 11 electrons. Now, if you drew the Bohr model for sodium, do I have anybody in here who I assigned sodium? Okay. On the first ring, how many electrons can I draw on the first ring?
On the first one, is
Yep.
it 2?
It's 2. Try that again. All right. On the second ring, I can draw how many? On the second ring, I can draw how many? Right. All right. So at this point, I have how many electrons drawn in? Mario, sit down. I've drawn in 10, right? I only want 11. So if I have 10 drawn in and I want 11, how many am I putting on the third ring? 1. All right. So this is the atoms problem. There are how many electrons on this ring right here? There is 1 valence electron. So it has 2 choices. It can either gain 7 more electrons, or it can lose 1 electron. Okay? Now, what would be easier for the atom? Atoms are like people. Okay? I tell people all the time, work smart, not hard. All right? You want to do the thing that will require the least amount of work that will get you maximum benefit. So, atoms are like that. They're smart. They're not going to work real hard if they can get what they need for the least amount of work. So, what would be easier for the atom? To gain 7 more electrons from someone, or to give away 1? Give away 1 is a lot more work, or less effort for what it needs. So it's going to lose the 1 it has. It is not going to gain 7 more. But some of you are like, how on earth is losing 1 going to get me 8 electrons, right? Anybody out there wondering that?
I kind of am.
Okay. Some of you probably see it. All right. Some people don't. So if we have 2 on the first ring, 1, 2, 3, 4, 5, 6, 7, 8, and the third ring goes away, this is the new outer shell. And the new outer shell has how many electrons on it? Because if this ring goes away and you lose that electron, how many electrons are now here? It has 8 electrons on the outer shell.
What about the two in the middle?
All right? It's not the outer shell. Go check.
But what is, never mind. Okay.
Okay. What's your question before you go?
If there's two in the middle, then isn't there 10 and not 8?
No, the 2 in the middle are on the inner shell, so they don't count. This is the outer shell, this one right here. And so this has 8. And they want 8 on their outer shell. And so that would be the new outer shell. Okay? Everybody with me on that? Yes or no?
Yes.
Okay, I'm going to do another one. We're going to look at group 2 and talk about it. Yes. Stop over there with no.
Send it.
Markel. As soon as I figure out how to operate this mouse again. I haven't had a mouse in so long, it's killing me. All right, so let's say we do magnesium. All right, magnesium has 12 electrons. Okay. All right, so if I draw the 12 electrons, got 2 on the first ring. There's 8 on the second ring. How many would I need on the outside ring, on the third ring? What? 2, right? So, I have 2 electrons. On the valence shell. So, how can I go about getting 8? What can I do? Okay, I can gain 6. Because 2 plus 6 will be 8, right? Or, what can I do with the 2 on the outside? I can lose 2. What requires less effort? Losing the 2 or gaining 6? That's right. We're going to lose 2 instead of gain 6. Okay, you're always going to go with a smaller number. Does that make sense? Now, we're going to lose until we get to what number of electrons? What do you think the magic number is going to be? We're going to stop losing.
Wait.
Nope. Does everybody have what they want there? Anybody have silicon in here?
No.
Silicon has 14 electrons.
Is this reactivity?
Yep. It's all building to reactivity.
This is what's gonna be like this?
Reactivity is not on the quiz tomorrow. The quiz tomorrow is just on labeling parts. I'm going to ask you questions about the parts on the periodic table. All right, so there's 10. So how many will I have on this outside ring if I need 14? I have 4. All right, so if I have 4 on that outside ring, what can I do if I have 4? Lose how many?
4.
Okay, so I can lose 4. Or I can do what? What's easier?
Losing
Either one.
it?
Okay? Here, it can do both. Okay? It can do both. It can do both here. Now, what happens once we go past the 4? Then it's going to do what? It's got to gain now. Once we go past the 4, it has to gain. It's no longer easier to lose. So if I go to, was it you who had sulfur?
Oh, yeah.
Yeah, I was thinking you told me earlier you had sulfur. All right, so if we go to Isella's sulfur, she had 16 electrons. So she had two, and then 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, and 6. All right, what are my options this time? Come here on that outside shell. I can lose 6 or gain how many? All right, if I have 6, am I going to want to gain 6? What's 6 plus 6? That's 12. I only want how many? I only want 8, so I'm going to gain 2. Now, what would be easier? Gaining 6, or sorry, losing 6 or gaining 2? Gaining 2. You're always going with a smaller number. Okay? You with me on that? Now, we're going to put this together tomorrow with reactivity. All right? Now, what is our homework tonight?
Study.
Study for your quiz. Your quiz is not on reactivity to clarify what Grace was asking. It's only on the parts, like what's the name of group 1? Which are gases? Which are liquids? What are the groups at the bottom called? What's the colored section? All right. How many valence electrons does group 16 have? That kind of stuff. All right. There's nothing on there about reactivity. Not on the properties of metals, non